Okay, we're
Oh yeah, it
recording.
does show it, top left.
Yeah, oh, you see the recording button?
Yep.
Okay, good. All right, so welcome to the first attempt at an online lecture. I hope it helps everyone, and we're gonna get started. Um, this is gonna be Networks 3. We're gonna talk about Lesson 3. We're gonna talk about other functionality on routers and switches. Sean's trying to distract me. No. Anyway, so that's what we're going to talk about. The first thing I want to talk about is the lab, because the lab in this one's going to be quite, what's the word I'm looking for? Involved. So let me share my GNS3 screen. There you go. You should see my GNS3 screen now. And if you look, I don't want to change documentation. I thought I locked everything. Let me zoom out here. As you can see, what we're going to do in the lab is we're going to have, by the way, in the lab, you're going to have to download this project and then import it in. When you do that, you're going to do File, and then you import portable project. You're going to click on the project you downloaded. It's called GNS3 project as a file extension. You can see it's only 36K. And then you can hit open, and you'll import that in, okay? Because I didn't pre-build this before the start of the semester, but the devices are already there. So what we're going to do in the lab is, and this is what we're going to talk about today, this switch right here is a layer 3 routing switch. So we're going to talk about how to set those up, okay? This is going to be a router on a stick situation. That's why I have trunk on here and multiple IPs. This is going to have sub interfaces. This is going to be the DHCP server for the butter side down people. By the way, the butter battle conglomerate is, so you're going to see it in the usernames and passwords. There's going to be lots of references to Dr. Seuss, the butter battle book. On the butter side down side, or the dev subnet, they're going to have the DHCP server be the router, and they're going to have the router have sub interfaces, and this switch is just simply a VLAN switch. On this side, on the butter side up, or the sales subnet, they're going to have this switch be a router and be a layer 3 switch, which I didn't document, but I have IPs on it, so that's kind of a clue. And also be the DHCP server. So you're going to set up the DHCP server here, DHCP server here. Finally, the fun part, you're going to have to get networking. So this is the internet, or the internet, as I like to joke around. And what I'm going to do is, I don't know why my head's crooked. Okay, there it is. So it's distracting to see yourself in the corner, because then you're like thinking about it. The internet's right here will provide internet connectivity. If I start this, for example, and I go into console, which makes sense because we'll be talking about this stuff, I'll be able to ping the internet, actually the real internet. I'll be able to ping 1.1.1.1. SolarWinds. I haven't changed this yet. Eat up my memory. I hate SolarWinds. Ping, I gotta install PuTTY on this. So if I ping 1.1.1.1, the actual internet, I can do it from the router. I've done some pre-config in here, but you've got a lot of configuring to do. So anyway, that's what we're going to be doing in the lab, and that's what we're going to talk about today in the lecture. Any questions so far? So the lecture is going to be relatively short. It's going to be relatively short for, I think if I do this, unfortunately, I don't see everyone's screen, or some people drop. No, okay, yeah. So that whole hand thing won't work, because I'm on my screen. I only see a small subsection of people. If you do have a question, just hit your space bar and ask it. Anyway, so that being said, the lecture is going to be rather light. Hopefully we get it done today. Maybe we'll take two lectures, but the lab is going to be quite involved. So, all right. I think we set the goal, and I'm tempted to, so I'm going to go back to my big video. Boom, hello. And then I'm going to do a screen share of my presentation. There's the presentation, and if I hit play, as some people have already connected to it, if I hit present, you guys should see a full, give me a thumbs up if you see a full screen. Okay, good. So we do have I'm gonna get this out of the way. Oops, I missed it. I'm gonna go back. We do have a Easter egg that I'll let other people click on and find, but reference the Bjork, making mine Gen X 1990s. References. So, all right. So big time functionality. All right. So the first thing we want to talk about is router on a stick. Remember, a router on a stick is that scenario where we have, I think I have, no, that's just DHCP. That's not, okay, that's relay. I was trying to see if I had a router on a stick drawing, which I don't. I've done one before. So tell you what I can do is I'm going to bring up, what do you call it there? A Sketchpad. Hopefully I can erase things now. Especially now. So I'm gonna have to share that instead. So let me do a new share to Sketchpad. Share.
That's art right there.
Yeah, you already saw it because it's just sharing out Chrome. Okay. So you can see my attempts to try to undo and it wasn't working. It's still not working. So I'm gonna gotta figure out what's going on there. I'm gonna do a new one. So remember, a router on a stick is a situation where we have a router, okay? And what we're gonna do is we're gonna have to go to a switch, all right? Now, this router is gonna have, and this is gonna be a trunk connection. This is why we call it a router on a stick, okay? So this is trunked, right? So we're gonna have multiple IP addresses on this interface, right? There's gonna be multiple IPs, and then this is gonna be a trunk port, and what we'll be able to do is have multiple workstations off of this on different VLANs. So we can have a VLAN 2, a VLAN 3, and a VLAN 4, for example, okay? And what we can do is, for example, so what we would have is if something on VLAN 4 wants to ping something on VLAN 2, it would come down this access port, hit this trunk port, go down to the router. Remember, when it goes on a trunk port, it tags the information, right? So the switch will sit there and say, okay, I'm setting this down a trunk port. This is from VLAN, this is on VLAN 4, so I'm gonna tag it as VLAN 4. The router will pick it up, read the information, look at the source IP, destination IP, and strip off the tag and say, okay, where do you want to go? Okay, that's on VLAN 2. Hey, I'm on VLAN 2, and literally pull a UE and hit a U-turn right here, right? Let everyone know that we're in New England, so we'll call it pull a UE. So we're gonna pull a UE, right? And send it down now VLAN 2. Now when we send it back, we're gonna retag it and say, hey, guess what, switch, this is gonna be a VLAN 2 data. So we tag it as VLAN 2, it picks it up off the port, it says, okay, cool, you wanna go to that MAC address, great, and you're on VLAN 2, great, I have that interface on VLAN 2, I'll send it. The reason why we call it a router on a stick, because this is ready, we have, most of the time when you set this up, you don't have the router with multiple interfaces like we're gonna have in our lab. You have it just with one interface, even though you have one interface actually plugged in. So you're gonna have multiple networks plugged into this one interface. That's why we call it router on a stick, okay? It's just a quick way to have routing between multiple VLANs, right? I can have a trunk connection, all of a sudden this router can be a router. Instead of having 4 different routers or have, you could, the other options you could have, instead of, if you say, I hate trunk ports, I won't do a trunk port, what you're gonna have to do is have a port from VLAN 2 go to an interface, a port from VLAN 4 go to an interface, and a port from VLAN 3 go to an interface, right? And then you can still do the routing, but you're eating up all these interfaces, okay? Does that make a little bit of sense on kind of a theoretical sense? Does anyone have a question?
Yeah. No, that makes sense.
Thumbs up. All right. All right.
I got a question.
Sure. Go ahead, Carlos.
So that square is a switch?
Yeah, I'm sorry. This is a switch. That would be a switch. Yep.
Okay, so everything's connected to the VLANs are connected to the switch, and then the switch is connected to the router.
Yep.
And then information sent from like VLAN 4, you were saying would come from the switch to the router with a tag saying it came from VLAN 4 and it was
Yep.
going to VLAN 2?
When we went down this trunk connection, we'd have to tag it. Every data except for the native VLAN, which again is a complication, and by default, we're not going to play around with native VLANs. By default, VLAN 1 is the native VLAN. Only that VLAN, and that's kind of why I avoided VLAN 1 here. Only VLAN 1 will not be tagged. It's the default. But like, so in this case, if this guy says, hey, let's give it an IP. Just say this is 192.168.2.1, right? And I'm 4.1, 192.168.4.1. And so my workstation says, hey, I want to ping, I'm 4.1, 192.168.4.1. I want to ping 192.168.2.1. right away my machine's going to look at my my subnet mask, say, hey, I need to go to the default router because it's on a different subnet. So it's going to send it down the switch, right? The switch is going to go to the MAC address of the router of the default gateway. This is going to be the default gateway for all these workstations. They're going to have different IP addresses and different MAC addresses. So what's going to happen is this workstation will send it down the wire. It'll say to the switch, hey, I want to go to this MAC address. Remember, a switch just cares about MAC addresses, doesn't care about IP addresses, right? So it's going to sit there and say, hey, I need to go to this MAC address. I'm on VLAN 4, and then the switch's database, the forwarding table, will look at it and say, hey, I have that MAC address, and it's on a trunk port, and it's on VLAN 4. Fantastic. I can forward it off. And then it'll forward it off down this trunk port. And when it does that, it's going to tag it just to make sure there's no confusion. This traffic was meant for VLAN 4. When the router picks it up off the wire, it's going to say, hey, it's headed to my MAC address. Cool. Let me strip off the VLAN 4. Great, it's VLAN 4. Let's just say it got weird, right? Whatever. Theoretically speaking, things got really crazy, right? And for whatever reason, I sent it to the wrong MAC address. There's an ARP table corruption or something like that, right? And I sent it to a MAC address on VLAN 2, the MAC address of the interface on VLAN 2. I would send that down to the switch and say, hey, I want to talk to this MAC address. And the switch would say that MAC address doesn't exist on your subnet, right? Because it doesn't. It exists on VLAN 2, not on VLAN 4, and it wouldn't forward it off. Again, and why we do this is just for simplicity's sake, right? I used to do it all the time because I'd rather just waste one interface on a router. It is a bit of a bottleneck. It can be, right? If I had like high performing machines here, one on VLAN 2 and one on VLAN 4, all traffic between those two machines, even though they're on the same switch, would have to go to that router and get routed through that router. Okay. Does that make sense, Carlos?
Yeah. Could you have like 2 trunk connections from the switch to the router?
Yeah. So well, from the same switch, you could do it and then have some VLANs routed on that other trunk connection. You can do what's called trimming, which we won't do in the labs, but you can trim the trunks. And as a matter of fact, when you set them up, let me real quick show you what we'll get there, but when you set them up, you could actually just sit there and say, I'm only going to support VLAN 2, 3, and 4, and then this other trunk connection going even to the same switch or a different switch will support VLANs 5, 6, and 7, right? So if you want to load balance that way off different interfaces, right? Because all those VLANs are going to have to share that. So if this is only like in our simulators, they're all Ethernet connections, so only 10 megabit connections. All 3 VLANs is going to have to share that 10 megabit connection, which is not ideal, right? So this is going to be a very busy wire. Every time anyone wants to go to any other VLAN, it's going to have to not only get sent down this wire, but sent back. So it could be a bandwidth problem, right? But functionality, it makes sense, right? Because that way I only have to plug in 1 port instead of plugging in 3 different ports. All right. I'm going to move back to the presentation, and we're going to actually see how it's set up. And we will be setting that up in the lab too. So let me hit present here. And we are going to set that up in the lab too, as well. All right. So here we go. Router on a stick. Again, a router connected via a trunk port. So the actual commands to configure this, right? We're going to be in config mode. So we go into config mode with config T or config terminal. We go into the actual interface. Now notice on the interface right here, I'll get my laser pointer up. All right, notice here on the interface right here, it's 0.1. So in this case, we have a gigabit interface, it's gigabit 00. I'm gonna go to 0.1, okay? So you can end up in an awkward situation, and this is gonna happen in the lab. If gigabit 00 is shut down, then all the sub interfaces won't work, okay? Once you go in there, if you notice it says config, it doesn't say config if, it says config sub if. So it gives you a little clue. Before you put an IP address, you have to tell it what encapsulation you're gonna do. Again, you're setting up a trunk port. So it's gotta know the encapsulation, in this case, .1Q, 2. Now, so this 2 means it's gonna be, this is gonna service VLAN 2. So 0.1 is gonna service VLAN 2, okay? And just to further confuse things, and just to show you it, I made, for whatever reason, VLAN 2 the native VLAN. So meaning when it goes sent down that trunk, it won't tag it. The native VLAN isn't tagged, okay? If I, on the other, it can get confusing. And on the other end, I can make another VLAN the native, and all of a sudden that VLAN becomes the other VLAN. Anyway, it can get confusing. That's why we're gonna just stick with not messing with native, and we're just gonna just do, we'll stay away from using native and keep the default, which is VLAN 1 on all interfaces are the native. But after you set encapsulation, you actually can do the IP address at that point. So we got IP address. In this case, I'm doing 10.1.1.1, and nice and simply, it's going to be on 255.255. Okay. Switches can do the same thing. If you have a layer 3 switch or a switch with routing, they can technically do the same thing. It's going to be done differently though. You would just give different IP addresses on different VLANs. We'll talk about that when we get to when we talk about the switches. So let me real quick bring up GNS3. Oh, let me guess, you guys did, and you guys don't see the putty, do you? Right now, if you don't see the term wins putty, do you?
Nope.
No. Okay.
Nope. Don't see it.
I gotta share that. I can only share one at a time. So I realized that earlier, and that's going to be an annoyance, but we'll make it work.
Can you full screen it?
It does. No, it's just you can only share one window at a time. So there it is, right there. I just can't show you the picture at the same time. So I'm in the router right now. So you didn't see it before, but if I ping 1.1.1.1, I have internet with this thing. So if I do a show run right now, I have an example of what a sub interface looks like in the real world, right? In this case, Ethernet 00, can I zoom in a little bit, make it more, I gotta put real putty up here, not this fake SolarWinds one. There, that didn't work. All right, let's go back. So anyway, if you notice right here, interface 00 is the WAN link. I got uplink LAN, I actually documented it, fantastic. Here's the IP address. That's a normal connection, that's normal, right? Interface Ethernet 01 is my trunked, you notice I say trunked uplink to switch 1 BBC down, butter battle conglomerate. This is where I'm gonna regret giving myself a tongue twister to keep saying over and over again. But BBC_down.com, right? So this interface looks kind of normal. Notice it's shut down too, so right now it wouldn't work either. Notice it doesn't have an IP address, right? Because we don't need an IP address on the parent interface, okay? But if I go to the sub interface, see how the sub interface has Ethernet 01.1. That's what makes that a sub interface, okay? I set the encapsulation at .1Q, because it's 1, it's native, that's by default. So it's gonna service VLAN 1, and I have an IP address. So this will be the default gateway for VLAN 1, this IP address right here, okay? If I wanted to go into, and you're gonna do this in the lab, if I go config T and I go in Ethernet 01.2, I can start configuring that interface too. So I give it a description of, I can do default gateway for VLAN 2. All right, and then I'm gonna do, if I try to do an IP address first, I'm trying to remember what the IP address scheme here was. 172.22.22. It's the last IP of one, so it'd be 126. 255.255.255.192 is the right answer, not 224. So you guys have to fix that in the lab. But notice right away it doesn't like that because I'm not set up for encapsulation first. Okay, so I need to actually do the encapsulation. So I do encapsulation. Oh, that's why actually, because I forgot to put address. That's sorry. I'm gonna do IP address. And then it's going to say, hey, idiot, you got to set up encapsulation first, okay? Thank you, Cisco, for actually giving me helpful error codes. So I'm going to do an encap first. If I do encap.1Q, and then we'll do I don't think I have to put VLAN, do I? No, just the number. All right, so VLAN 2, and then I do that command. Everything's happy and good, okay? By the way, I can shut down sub interfaces. So if I do a shut, I can shut it down, do show run. And here's the command, here's what I'm working on. Notice how it's shut down, and I can of course then do a no shutdown if I want to bring it up. No shut. and it brings it up. Okay, if I do show run again, and this time I'll begin at 0.1.2, so I'll start right there. What happened there? Oh, there it is. Okay, it did what it told it to. All right. As you can see, there's a configuration I just entered in. Okay. So what I just did was I created an IP address on a sub interface that is set for has an IP address of 172.22.22.126 with subnet mask 255.192. It's doing encapsulation .1Q. It's going to be servicing for VLAN 2. So when the traffic between, let me go back and share, new share. When it goes between this trunk connection, this is the interface we were just configuring. I can confirm it by doing a show interface. Oh, it is right there, E01. When I send the traffic down this trunk port, it's going to tag it as VLAN 2. And we're going to have to configure a trunk port on the switch as part of the lab. So that's what we just did there, all right? Hopefully by doing it in the lab, it's going to make more sense, you know, actually getting your hands on it and experimenting with it. You'll see it, and once you do it, it will be a little bit more sensible. Any other questions? I mean, I know it's a new concept, so it might be a little strange. I'm gonna drink a little coffee.
I do have a question.
Yeah, Adam.
I took a quick note about something you were saying, and basically in the commands that are on the slide, when you specify the sub interface like 0.1 of like it's 00,
so this one right here, interface commit 00.1.
Right. So specifically going to that sub interface, the command below the .1Q2 native. So you said that you are specifically assigning that sub interface to service VLAN 2, which is specified specifically by the 2 below there.
Yes. So it's a confusing situation because we're not lining up our numbers. But in this case, we have, and I don't know why I did it this way, maybe to try to confuse you to help learn, you know, understand the concept. But interface gigabit 00.1 will be the default gateway for VLAN 2 in this scenario. And it's going to have an IP address of 10.1.1.1 with a 24-bit mask.
And that would be the IP address for the sub interface that's being configured.
Correct. Yep. And that would be the default gateway then for, or potentially a default gateway for VLAN 2. It'd be a router that has an interface on that subnet of 10.1.1.0, and it could route people off potentially.
All right, that makes sense. I guess what you were saying before then is normally you try to line up the sub interfaces with the VLANs that they're servicing. So like .2 with VLAN 2.
Yeah, you can technically do whatever you want, but it's considered good. What's the word I'm looking for? Good order or good just
best practice.
Yeah, best practice. Thank you. It's the best practice to try to line up your sub interfaces with your VLANs. Again, I've gone as crazy as having the natives change. So I had a native VLAN on a router that I made the router. I made it the native VLAN. So when it went over to the switch, that became VLAN 1, even though on the router, it understood it as VLAN. I'm trying to remember right now, it was like 106 or something. So you can get crazy with things, and it's powerful, and you can build yourself a house of cards, right? So one of the key rules of being any kind of decent network engineer or any kind of sysadmin is do your best to keep it simple, stupid, right? And part of that would be lining up the numbers with the VLAN, the sub interface number with the VLAN. Any other questions about router on a stick? I know it's not the greatest situation to learn it, but I think if you do a little bit of hands-on and when you set it up in the lab, it might all of a sudden make a little bit more sense. All right. So this is more, I think we'll finish, we'll get DHCP working. It's 10:30 now. We'll see how I think DHCP will be a lot easier because it's a concept we've already dealt with. All we're going to do is we're going to get DHCP up and working, okay, on a Cisco device. Let me, there you go. So DHCP, again, So one of the concepts that we talked about is why would we have DHCP on a router or a switch? And believe me, this is a debate I've had often. A lot of people prefer to have it on routers. I would say the default for any large company or mid-sized to large company is to have the DHCP server tied in with Active Directory. For folks that took Networks 2 and more so Windows 2 last semester, would see why, right? A DHCP server tied into Active Directory kind of gives you all kinds of power as far as, you can tie them together a little bit better, okay? If you're on a really small company though, you can make the argument of why are we buying a DHCP server? And why, again, you know how much I love servers. As a former network admin, I would argue against them all the time and say, I got bad news, guys. Your server goes down all the time. It's got moving parts, right? It's not, it's not as good. So again, it's an active debate. Often we don't, you don't see Cisco devices run DHCP, and if they do, it's usually in like a quick little ad hoc type situation. But it's something it can do, and it does it well. All right. So let's look at how we would configure it. First thing we want to do is exclude the addresses. Remember, we set up a DHCP server last semester in Networks 2 for folks that had me in Networks 2. Again, you always are going to have IPs you want to hold in reserve. And so what you can do is do excludes. Now, Cisco it's got a somewhat fully functioned DHCP server, but it's not as full function as a normal DHCP server. And the way it works is you're going to define the network with a network command. We'll see that in a little bit. And then it's going to hand out every IP address in that network. Now you can use exclude in the global, by the way, it's applied globally. You can use the exclude to say, don't hand out these IP addresses. But by default, if you don't do any excludes, it's going to hand out every IP in the subnet, which of course is a disaster because if you think about it, the default gateway at the very least is going to have an IP address, and you may have an IP conflict, and that's not good. Okay. You're going to set up your excludes first. Ideally, you could still set up DHCP without excludes. It's not ideal. And certainly if you're doing this in a production environment, you want to do your excludes first because especially if they're on the lower end, Cisco hands out IPs from lower to higher. So if you don't do your excludes, as soon as you set up DHCP and the first workstation boots up, it's going to grab one. And if that's the IP of the default gateway, you got an IP conflict. That's a problem. Okay. Next thing you can do is you create a pool for each subnet. We're going to start using this term pool a lot more. A pool is a collection of IP addresses in the world of Cisco. Anyway, we're going to be using that terminology more and more. Okay, so you're going to set a pool up. Now, you can name your pools, and I'm going to do it both ways in the labs because I've seen technicians do it both ways. So you can set up a pools calling it, in this case, my example coming up on the slide, I think we called it tech wireless. So it's clearly like a technical wireless network, right? And we're going to call the pool tech wireless. What I prefer to do when I did it, because I'm stupid and I'll always forget, I don't remember what the subnet for tech wireless is. I just put the subnet in. So I would put, if it's the subnet is 192.168.0.0/24, then that's what I would put. I put 192.168.0.0/24 as the pool name. Now that can cause confusion because later you're going to use the network command to actually let the pool know what network it's servicing. So I often do that and students get confused and say, oh, I thought I told it what network it was in the pool command. I'm like, no, you do it in the network command. I'm just an idiot, and I put the subnet as part of the pool name. So you can call a pool whatever you want, including the subnet it's actually servicing, which is what I prefer to do. But there's no right or wrong on that. Okay. Choose the network ID and the subnet mask for the pool that the server will provide, and we're going to use that what's called the network address. Then you add the address for the default gateway. You can provide a DNS server if you want your users to have internet. If you don't want to use the default lease time, you can change it. We're going to do that in the lab as well. So this is what it looks like. Okay, so when it's all said and done, this is the actual commands. All right, I'm going to move this out of the way so I can. All right, so in this case, again, we're in config mode. So this is global. And this is going to affect every single pool. Essentially what you're telling the router or the switch, in this case the router here, but switches can be DHCP servers as well. What you're telling the router is do not hand out any IP from 250. So don't hand out the IP 250 or don't hand out the IP 254 and nothing in between. So there's a space here between this font doesn't do a good job of showing spaces, but there's a space right here between the two of them, okay? So I've set up this exclude. I told the router no matter what, never hand out the IPs 250 to 254. Once I set that up, now I can go into, well, I mean, now that I've done best practice and set up my excluded first, I can set up the pool. So in this case, we have a normal name, IP Pool Tech Wireless, okay? Which is, again, something I see in the industry all the time. I see people put IP Pool, right? I see people put DHCP Pool. They put the purpose of it and then a descriptor. That's fine, right? In this case, what I would normally do is I would put IP DHCP Pool 10.0.0.0/24 just to let me know which, what pool does this, or what network does this pool serve? But again, it's up to you. So once you create that pool, notice it's going to go DHCP-config. That's the mode you're currently in. So you're in the pool. You're actually in the pool configuring it. And the first thing you should do is tell it, hey, by the way, this is the network you're going to serve. Now, the way it works is the router is going to sit there and listen for DHCP broadcasts, DHCP request broadcasts, right? And what's going to happen is it's going to come in off a certain interface, especially for the router. And the router is going to know, based off that interface's subnet, what IP it's supposed to handle, right? So if it comes in over the subnet that has, let's just say, the default gateway is 254. So, and this is the router. So let's just say this is the router. It's going to come in and it's going to say, oh, this request came from the 10.0.0.0/24 network. So therefore, I'm going to hand out an IP from that range. As a matter of fact, it's going to hand out the first one. It would hand out 10.0.0.1. That's how Cisco works, okay? Next thing I'm gonna do is, if you want a machine to get off its subnet, it's gonna need a default gateway, a default router. So I type in default router, 10.0.0.254. This goes back and forth on different versions of iOS. Sometimes it's default gateway, sometimes it's default router, so keep that in mind. I think it's default gateway in our lab. So keep that in mind. And you can always say question mark to make sure, figure out which one it is. And then I can give it a DNS server. So in this case, we have 250 apparently as a DNS server. I'm going to give it the DNS server 10.0.0.250, and then space, I'll give you a backup DNS server, in this case 4.2.2.2. Okay. In our lab, we're going to do 1.1.1. So let me share out that PuTTY connection and show you what it would look like here. If I wanted to set up an IP pool for the first sub interface here, which I don't have on display. So let me do a do show run. Oh, that's where my problem is. I knew my Spidey senses told me I had a typo somewhere. And I'm going to begin it at 0. We'll just begin at 0.1. Nope, I forgot the bag. What? Do show. Oh, I forgot the run. There you go. So I do a do show run, and here I am. I'm going to set up a IP pool for this network right here, which, by the way, has the wrong subnet mask. It should be 192. So that was my mistake. Something you're going to have to fix in the lab. Sorry about that. So I'm in global config mode, so I can do IP DHCP exclude excluded address, and on that network 172.22.22. I want to exclude all the possible last IPs. So I'm going to exclude, we'll do from 57 all the way to 172.22.22. The default gateway, which is 62. 63 is the broadcast. It won't hand that one out. Okay. So I set up that exclude. Now I can go in the pool, set up the pool and do it. So if I do a pool, I'm going to do, is it DHCP pool? IP? DHCP pool? Yeah. DHCP pool. And then I'm going to, again, this is the way I prefer to do it. I'm going to have you do it both ways in the lab. But in this case, I'm going to do 10.22.22.22. slash, or that's a 0 slash, and it's the first 226. So there I go. I've set up the pool. Now I'm going to tell it what the network is, network, and I'm going to tell it you're going to do 172.22.22. And by the way, cool thing in this 0, if I put a question mark, then I have to put a space, but I can use the CIDR. So that's why I did a question mark right there. It tells me I can both put the subnet mask if I want, or I can do a CIDR. So we're going to be cool, and we're going to do a CIDR because it's always good, quicker to type out a CIDR. So I'm going to type in a CIDR. I'll do a default router. There I am. So 172. I was wrong. 250. Nope, it's 62. Got a little ahead of myself. And then we'll do a DNS server of 1.1.1.1. Unfortunately, there's a lot more config to go into this before I have to set up the switch, before we could actually see it in action. Although I am the native VLAN, so let me, I'm going to share out I'm going to boot this up. And you're on VLAN 1, so I think this might work. Let's see if I get an IP address with no config. Oh, I have to set this up as a trunk, though. It would definitely need, not really, because it's native. That might work. Let's try it. I'm going to see my workstation. I'm going to start the workstation. And then I got to console. Actually, I'll do auxiliary. Well, I'll do console. Bring up the desktop, but I have to share it now. So I'm sharing out my VNC. There I am. There's my workstation coming up. And unfortunately, I have to scroll down. They bring up terminal, and I'm going to see if I got an IP address. I'm not sure if this will work. I might have to configure this, but we'll give it a shot. Didn't work. Yeah, it's not getting an IP address. Sending packets out, but it's not getting an IP address. All right, so yeah, the switch probably needs some more configuration, particularly on the trunk port. So anyway, I'll stop the share and get back to my desktop. So, but in the lab, you'll see that you're going to actually, this is the lab that you're actually going to be doing, and you're going to get IP working with Dhcp coming from this router on the butter side down, folks. On the butter side up, folks, you're going to be setting up this switch as a Dhcp. So you're going to do it twice, and in the switch, you're going to be using the name of the network. So. All right, let me go back to sharing the slides, and I'll close VNC because I don't want to, I mean, it's tight VNC.
I have a quick question.
Sure.
In that network configuration, the putty that you just had up when you were...
I'll put it up there. Give me a second.
Okay.
Where are my options here? Oh, there I am. Share, let me share putty. There I am. Oh, that's my switch. Okay, let me go back and share the other putty.
When you were assigning the network, Pool was going to draw IPs from, and you could have used CIDR. It looked like it gave you the option to use like classful letters, A, B, C, or D. Was that?
No, that was just the subnet. When Cisco says, "Hey, give us a subnet," that's how it notes it. Let me.
I didn't know if that was like a shortcut for you to say like use class A IP range, so it's like slash.
Well, ironically, it's a slight reference to it. Let me get into it. Config T IP. Actually, I can up arrow. Let's go back into that pool, and if I go to network, right, and I do a question mark here. Yeah. So this is what you're talking about right here.
Yes.
Yeah. So ironically, it is a reference to Class A, Class B, Class C, Class D. But what they're letting you know is I can't do that. I can't just say A, for example, if I want to do like a Class A, or it's a Class C. So if I want to do C, it's not going to like that. What they're saying there is I want 255.2. They're just saying you need to follow this. You need to follow this format is what they're saying.
Okay. All right.
In this case, it's a 192 network. So I hit enter. It'll take that as information, right? So if I do show, I keep falling for that. Show, run, include DHCP. Yeah, pool. Oh, I should just do begin DHCP. So there's my DHCP pool right here in my config. Now you see I changed the CIDR to a subnet mask. But it is kind of a sly reference to it because if you notice, the first subnet is marked A, the second subnet is marked B, the third subnet is C. And in theory, a Class D network would have be subnetted out on the last octet. So anyway, fun stuff. It's almost like inside Cisco humor, which is sad and pathetic. But there you go. Did that answer the question?
Yes, thank you.
Okay. All right. It's 10:48. So yeah, it doesn't want me minimizing. So let's look where we're at in the presentation. We went over, a couple more. I'm going to talk about troubleshooting DHCP, and then we'll call this a part 1 of a lecture. I think that's the plan. Fun things. First of all, in the world of Cisco and a couple other places, we talked about this last semester, networks too. Another popular phrase for a DHCP IP assignment is an IP binding. We call it a binding. We're binding an IP to a host, right? And so if you want to see your bindings, you want to see the addresses you've handed out, you can, at enable mode, or privileged exec mode, whatever you want to call it, but enable mode, which is what I prefer to call it. You type show IP DHCP binding, you'll actually see your IPs that you've handed out. So it's pretty cool. You can also look at a pool's config by doing show IP DHCP pool and the name of the pool. In this case, we went in the slides, we named it IP pool tech wireless. You can look that up. You can also look at your statistics. How many IPs have you handed out? How many do you have in reserve? And then as part of troubleshooting, if the device picks up a conflict, I have 2 devices using this IP address, you can do show IP DHCP conflict. That could be useful if you have your troubleshooting. War story for me, I was troubleshooting a network that some users were calling up and saying, hey, it's not working, and I'm getting a message about a conflict. So I really went in quickly and did show IP DHCP conflict, and it listed all the IPs that router had handed out. Turns out someone else was like messing around with the machine and turned their machine into a DHCP server. They were trying to get something else working. It was a programmer. And they were handing out IPs on that subnet, and I was getting conflicts. The Cisco device was smart enough to say, hey, I handed out this IP. It's fine in my database, but for whatever reason, we're getting a conflict on it. So I was able to do some quick troubleshooting. So these commands are useful. I don't think I had you do them in the lab. It was something I forgot, and the lab was enough anyway. That's big enough, believe me. So anyway, these are the commands that will help you, and I probably should have had you do it in the lab, but I'll make you do it in the project, that's all. Anyway, let's talk about DHCP Relay, and then we'll call it a lecture. All right, real quick, DHCP Relay is something we're not going to do in the lab, but what DHCP Relay does, and I worked on this drawing here, is with DHCP Relay, what I'm able to do is relay instead of answering a DHCP call. So remember, a lot of times in networks, particularly Active Directory networks, we're going to have a DHCP server sitting on the network. And instead of having a DHCP server per subnet, what I can do is have the router relay the request over to a DHCP server. So the way it works is this machine right here, this workstation. We'll make it this workstation over here. This workstation over here. Let me get my laser pointer. This workstation over here makes a DHCP request. Being a broadcast, the switch just forwards it off, right? The router picks it up. Now the router's been set up, in this case, it's got the wrong helper address. I should have made that match. I didn't make that match. So ideally what I would do is on the interface, every interface that I wanted to listen for broadcast, I go into interface, I type IP helper address, and then the address. So in this case, I'd actually put 10.162.1.101. And what that says is, hey, this particular interface, if this was gigabit 00, if it saw a broadcast, it would say, hey, this is a DHCP request. Let me forward it off to that IP address. Being a router, it can forward off to an IP address. It knows IP routing. So what it would do is just forward off to that server and say, hey, server, I found this. The server, for all it cares, doesn't care. It has the scope set up. And the scope will simply say, okay, cool, what subnet does this come from? And that would be recorded in IP source. In the IP source field, the router would put the subnet or its own IP address, which would include the subnet of that's making the request. The DHCP server would check for a scope and say, okay, cool, I have IP ready to go on that scope. and it would forward it back to the source IP address to the router, and the router would relay that back to the workstation as a normal request. The workstation would be none the wiser. It's just a sleight of hand that the router is doing. So that's called Dhcp Relay. It's a quite common feature. Again, as many shops that have Active Directory, you're going to see a lot of DHCP servers as the sole single DHCP server on a network. And if you do that, if you only want one DHCP server, you're going to have, because remember, a normal DHCP request is a broadcast. What do routers do with broadcasts? They drop them. This is one kind of caveat to it, where a router can be programmed with the IP helper address command to relay the information to a DHCP server. Okay? We will end it with that. So this will be part one. We have a number of slides left where we're going to talk about NAT. And NAT is a pretty complex concept. We're going to go create, you just can't simply have NAT. This is not your home router. Welcome to Cisco. We're going to get really complex, including understanding what inside, outside, local, and global is. So that's a little preview. So we'll talk about NAT, and then we're going to talk about setting up a routing on a switch. And then as like a little quick throw in, we'll talk about network time protocol, because I have nowhere else to put it. So it got thrown in here. It's 2 commands. It's no big deal. And I forgot to do it in our lab as well, but that's okay. It's not a big deal. All right, so we covered router on a stick, and we covered DHCP. And then next lecture, we'll talk about anything else. That being said, are there any questions for me?
Oh,
As usual, I went a little over. Nate?
I think we're good. Sorry, I forgot the push to talk kind of takes a second there.
All right.
No, I guess, no, makes sense for now. I have like a cursory or more of a general understanding. And then I think when I go back through my notes, I'll be able to.
And hopefully when you do the lab, I'll have the step-by-step instructions on the lab. Although on stuff you've already done, I don't have step-by-step. I tell you just set the host name. So that's coming up.
Yeah.
But I'll give you, on setting up this stuff, I'm actually like, you're going to set up 4 DHCP pools. The first one, I tell you exactly. The second one, I give you a script to set up. And then third and fourth, I have you do it on your own. So hopefully, like by the time you're done, you're going to go, I hate setting up DHCP pools. I'm sick of it. And then you set up 2 more, by the way, on the switch. So you're going to be setting up a lot of DHCP pools. You're going to be setting up router on a stick. That's the more complex concept. But again, it just comes out, all you're doing is you're creating logical interfaces that are going to exist under a physical interface. And that one physical interface will then all of a sudden magically, let me share out my Chrome, and then I'm going to get off full screen, I think. Come on. And then I'm going to bring up Sketchpad. Again, that one single interface is going to be the router essentially for all the possible IP. So in this case, we have 3 different VLANs. So we'd have 3 different IP addresses. And that one interface now becomes the default gateway for all those VLANs. Hopefully when you execute it in the lab, it'll make more sense. But anyway. All right. Any other questions for me?
Professor, I have one question.
Yeah, Mo.
So when you assign, when you exclude DHCP addresses, should it be a range, or can you exclude in multiple?
You can do a single. If I remember correctly, it's going to want a range. If you want to do a single, you have to sit there and say, let's say you want to exclude 10.100.100.100. That's the only IP you want to exclude. Then you'd have to do IP exclude 10.100.100 space. And this is where I might be wrong. You might be able just to put one IP. Again, context syntax changes per version of iOS. So, but in the past, I remember having to put 10.100.100.100 space 10.100.100. Put it in twice. So you're setting up a range of 1, right? But sometimes you have to do that, and it's counterintuitive. Again, the problem with Cisco is once you set that network command, you're telling it what network it's going to do, and it's going to hand out every IP in that whole network. So you're going to have to set up excludes, because at the very minimum, you're going to have a default gateway in that network, but you probably also have other servers or printers or something, and you're going to have to set those up. So if you have them all in a range, a lot of times when I set up networks, I would use 24-bit mask just to keep things simple. And then I would say anything above 200 and above was administrative. Like I will never hand that out to users, right? That's where we'll put our printers, our servers, or wherever else we want to, IoT devices, voice over, whatever it is, right? That's where we're going to put. We're going to reserve everything above 200. So those are 50 odd addresses, 52 that are usable. I'm sorry, 54. 54, 55. Actually, 55. Anyway, those 50 odd IP addresses will be only used for administrative purposes. I would do an IP exclude. Let's again pick on 10.100.100.200 to 254. So it won't hand out the broadcast. It won't hand out the broadcast because at least gives Cisco credit for that. John, do you have a question?
Yes. When we're creating sub interfaces on the router itself, I'm assuming that we would have to do the same on the switch to assign those ports to whatever we have those sub interfaces for.
We'll talk about that next lecture, but with the switch, what you're going to do is you're going to have at least one interface running IP. You're going to have to enable IP routing on the switch, but then what you can do is you can just assign IP addresses to the VLAN interfaces and they become routers. We'll talk about that. It's a little extra complication. All right. Any other questions?
Okay. So the next set of questions. I mean, the next set of the slides that's going to be held on Wednesday.
Yeah. So thank you. Thanks, Chris. Yeah. Next meeting will be on Wednesday, same bat time, same bat channel. So it'll be at 10. 10. We'll start connecting up at 10. And then we'll get started at 10:10, and then we'll cover the second half of the slides. So there you go. Whoop, I'm getting my internet connection is unstable. Message. Anyway, so I don't know if I warped out there. My audio went a little haywire. Anyway, so yeah, we'll be meeting up we'll start meeting up around 10, and then we'll get started at 10:10.
All right, sounds good.
All right, I'm gonna stop recording.